Hi, welcome to my YouTube channel. Today we will be solving the question of swapping nodes in a linked list. So we are given a head of singly linked list and an integer k, and we have to return the head of the linked list after swapping the values of kth node from the end and kth node from the beginning. So here we are given this singly linked list where the head of the linked list is at node 1. So here is the head and k is an integer and the value of k is 3, and we have to swap the kth node from the beginning, which is the node 3 here, and kth node from the end is this node 7, and we have to swap these two nodes. So we can either swap the values of the two nodes or we can swap the references. So swapping the values would be really simple, and it's not recommended to simply swap the values because this is a linked list problem. So what we are going to do is we are going to look into swapping the pointers instead of swapping the values. So after swapping, my node 7 is going to come here between node 2 and 4. So 2 dot next would be at node 7 and 7 dot next would be at node 4, and my node 3 is going to come here. So 6 dot next will be here and 3 dot next would point to 8. So let's see what we are going to have to do to solve this question. So this question will involve initial two steps. So the first step is going to be finding the kth node from the start and the previous node, and the second step is finding the kth node from the end and its previous node. So we can find the kth node from the start using k minus 1 iterations, as we are starting from head and we just need to do two iterations, one and then two. In two iterations I will reach my node 3, and we also need to store the previous node before the kth node from the end. So previous node before node 3 is going to be node 2, so we are also going to need to store that. And to find the kth node from the end, we can find that using slow and fast pointers, and we covered that in our previous video where we solved the question of deleting the kth node from the end. So you can see that video, or I'm going to cover, or you can see it when I'm writing the code. So let's draw a few more examples to understand this question. Also, the range of k is from 1 to length. So k is greater than equal to 1 and less than equal to length. So because if k is in this range, then p1 and p2, so p1 here is the kth node from the beginning and p2 is the kth node from the end, they are going to be non-null. And if k is greater than length or k is less than 0, then p1 and p2 are going to be null, and these will be invalid cases, so we don't need to worry about these cases. So let me call this node 3 as p1 and my node 7 as p2. So let's draw a simple case and try to understand this question. So here we have the same example, and my p1 node will be node 3 and my p2 node is going to be node 7. So this is after we have found the kth node from the beginning and kth node from the end. And as we are finding p1 and p2, we are also going to store previous node, so p1 previous and p2 previous, and also p1 next and p2 next, because we are going to update p1 dot next and p2 dot next. That is why we save the next references as well. And also because this problem is going to use previous pointers, that is why we are going to have to use dummy nodes. So this is just for simplicity so that we don't encounter null pointer exceptions. So after we have found p1 and p2, we have to update our pointers to swap these two nodes. So what we have to do is we are going to have to update p1 previous. This pointer is now going to point to p2. So p1 previous dot next is going to point to p2, and p2 dot next is going to point to p1 next. So what's going to happen is 2 dot next is pointing to 7, and 7 dot next now points to node 4. So this way my node 7 is going to come in between node 2 and 4, and similarly p2 previous dot next is going to point to p1, and p1 dot next is going to point to p2 next. And once we have done this, we would have swapped p1 and p2 and we would be done. So there are going to be two special edge cases. So let's try to understand those two edge cases. So the first case is when p2 is equal to p1 dot next. So for these edge cases, we don't need to do all these 4 pointer updates. So let's try to see what we can do instead. So here we are given this example where linked list is of length 6 and k is equal to 3. So as you can see, my p1 is going to be node 3 and p2 is going to be node 4. So as you can see, p1 dot next is equal to p2. So in this case, we know that we have to swap the node 3 and 4. So the node 4 should be after node 2 and node 3 should be before node 5, and p2 dot next should point to p3 after reversing. So here what we have to do is, let's try to update some pointers. So I'm going to update my p1 previous dot next is equal to p2. So when I do that, my node 4 comes after node 2. Next I can do is I can update my p2 dot next to p1, and next I have to update my p1 dot next. So my p1 dot next is this, and this is going to be updated to p2 next. So I simply need to update these 3 pointers. So the first one is p1 previous dot next is equal to p2. Then my p2 dot next is going to be equal to p1, and p1 dot next is going to be equal to p2 next. And these 3 pointer updates is going to swap the 2 nodes. And my second edge case is when p1 equal to p2 dot next. So in this case, let's try to write the pointers. So my p1 next is going to be this. So here k is equal to 4 and p1 is going to be node 4 and p2 is going to be node 3. So p1 next is my node 5 and node 4 is going to be p2 next, and node 3 is going to be p1 previous, and my node 2 is going to be p2 previous. So in this case, what we can do is we have to update p2 previous dot next to p1 and p1 dot next to p2 and p2 dot next to p1 next. So what is going to look like is p2 previous dot next is going to be equal to p1, p1 dot next is going to be equal to p2, and p2 dot next is going to be equal to p1 next. So in the code, what it's going to look like, so after we have found p1 and p2, we can simply add if checks. So if p1 dot next equal to p2, then do those 3 pointer updates, and else if p1 equal to p2 dot next, then do those 3 pointer updates, and else do those 4 pointer updates. 4 pointer updates, and then 3 updates here, and then 3 updates here. And this is going to cover all of our edge cases, and in the end we can simply return dummy dot next. So using the dummy node, it was helpful for finding the kth node from the end using slow and fast pointers, and it also helped us avoid null pointer exceptions. So let's try to write the code for this question and understand this better. So now let's have a look at the code implementation of this problem. So here we have to implement this function swap nodes, and we are given the head of syncly linked list and an integer k. So as discussed from our algorithm walkthrough, we need a dummy node. So let's create a dummy node first. So list node dummy equal to new list node -1, and dummy dot next is equal to head. And next we have to find the kth node from start and kth node from end. So let's find kth node from start. So for kth node from start, we have to do k-1 iterations. So let me create a variable count equal to k, and let me also create a variable for p1, and let me initialize it to null, and let me create another one p1 previous, also null, and we need p1 next as well. So we initialize these three variables to null. So to find p1 and p1 previous, we're going to need a while loop. I'm going to do while count is greater than 1, and the end I have to decrement count. And initially, instead of setting this to null, what I can do is I can set my p1 to head and p1 previous to dummy, and this way I can move both of them forward by one step. So p1 previous equal to p1 previous dot next, and now I can set my p1 next. So p1 next would be equal to p1 dot next. So what I can do, I can create p1 next here instead and remove from here. So next I am going to find the kth node from the end. For that I'll have to use slow and fast pointers. So the initial step in slow and fast pointers is to separate the slow and fast pointers by k nodes, and I'm already at kth node, so we wouldn't need to do that step again. So what I can do is I can set my slow pointer to dummy, and my fast pointer is going to be same as p1. And now what I can do is while fast is not equal to null, I can increment my slow pointer, slow equal to slow dot next, and fast equal to fast dot next. And at the end, what is going to happen is when my fast pointer becomes null, my slow pointer will be equal to p2, would be the kth node from the end. But here we also need the previous node before the kth node from the end. So what we can do is, instead of checking fast is not equal to null, we can check fast dot next is not equal to null, and this way my p2 previous will be equal to slow, and my p2 is going to be slow dot next, and my p2 next is going to be p2 dot next. And now we have found p1 and p2. Now we can add the if checks. So first one would be if p1 is equal to p2 dot next, else if p2 is equal to p1 dot next, and the remaining cases. And at the end we can simply return dummy dot next. And as we discussed, for the case where p1 is equal to p2 dot next, for that what we have to do is we have to update three pointers. So p2 previous dot next is equal to p1, and p1 dot next is going to be equal to p2, and p2 dot next is going to be equal to p1 next. And for the second case, when p2 is equal to p1 dot next, for this we can do p1 previous dot next equal to p2, and p2.next equal to p1, and finally p1.next equal to p2 next. And for the else block, we are going to need 4 updates. So the first one is going to be p1 previous dot next is equal to p2, p2 dot next is equal to p1 next, p2 previous dot next is going to be equal to p1, and p1 dot next is going to be equal to p2 next. So this would be the final check. So you will not be able to understand this question if you don't draw diagrams. So I highly recommend to draw the linked list diagrams first in order to understand these pointer updates. If you don't draw diagrams, then you won't be able to understand it. So please draw diagrams. Okay, so now let's try to run it and see if it compiles. So yeah, that works, and let me submit it. And yeah, that works as well. So I hope this made sense, and if you have any doubts, let me know in the comments, and I'll see you in the next one. Thank you.